On the chart, right, which numbers do we want to see, do go over, have questions about? Okay. Majority 2s and 3s. If you had something other than a 2 and a 3, keep your hand ready. So if you had a 2 and a 3, 2 or a 3, you can put your hand down. Of the ones left, I see 1. So we'll do 1, 2, and 3. For number 1, given this equation, identify the x and y intercepts. Well, the y intercept is pretty easy because it's already there. So 0 and 4. The x-intercept we have to solve for, put 0 in for y. And solve. Get rid of 4 by subtracting. And divide both sides by 2. So that intercept would be -2, 0. So those would be your 2 intercepts. Questions on either of those? For number 2, we have to write the slope-intercept form of the equation of the line through the given point and slope. This is our point, this is our slope. So normally you would do your y minus y1 equals m times x minus x1. But because the slope is undefined, we cannot do that. We have to think of what type of line would have an undefined slope, which would be an x equals. Look at what your x value is, and that would be your. So for those, there's really no work to do. You just have to know that. Questions on that one? For number 3, we have to find the slope between these 2 points. These are x1, y1, x2, y2. We're going to do -2/5 minus 3 all over -5 minus 2/3. We have to get common denominators. So right now the whole numbers are really over 1. So in the denominator, I can make it 3, so multiply it by 3. And in the numerator, multiply these by 5. We have -2/5 minus 15/5 all over -15/3 minus 2/5. Then we could simplify both. Subtract across, so we have -17/5 all over -17/3. And then from this point, you could either put all of this in the calculator all at once, or you could take the denominator fraction, flip it, and multiply to both. The entire denominator cancels out, the 17s cancel out, the negatives cancel out, so m equals this. Questions on that one? So as I mentioned before we started linear regression, this is really 2 short units combined into 1. So we're going to start the other one today. When we come back, we'll review and you'll take the quiz, and then there'll be a flex day in there somewhere, and then we'll go over the quiz, and then you'll take the test. So everyone should have these notes on their desk. Alright, so some vocab before we start. A direct variation is a specific relationship in which there is a constant ratio between all ordered pairs. Direct variation equations are written in the form y equals kx. So the ratio that they're talking about is how we find the k value, the constant. So if I were to take this equation and solve it for k, how would I get k by itself? Divide x on both sides. So we have k equals y divided by x. That is the ratio that it's talking about. So we're going to use that ratio to find our constant k in this next piece. So the constant, first let me back up. The equation, our direct variation equation, is very similar to our slope-intercept equation, but different also because we have k, not m. Our constant k is like m, but not at the same time. It has different names: constant, constant of variation, constant of proportionality. It all means the same thing. But in order to find a constant, we have to use that ratio, y divided by x. So we're going to divide each of these and see if we get the same constant for all of them. If we do, we have a constant, it's direct. If it's not the same for all of them, then we don't have a k, it's not direct. So for each of these, let's divide our y by x. So 4 divided by 1, 8 divided by 2, 12 divided by 3, and 16 divided by 4. What would those be? 4 for all of them? Yes. Because it is 4 for every single one, that is our constant value, it is 4. So because our k value is 4, we can write the equation, this is direct. So we would write it in the y equals kx format as y equals 4x. Questions on that so far? All right, let's do one in the table, number 3. Same thing, divide your y's by x's, so negative 8 over negative 12, negative 4 over negative 6. We'll come back to the 0 over 0, and then 2 divided by 3. When you put that into the calculator, if you're using that, make sure you're putting it in fraction form, so alpha y equals. Negative 8 over negative 12 would give us to divide both by 4. 2 over 3. Negative 4 over negative 6. Also 2 over 3. We can't divide 0 over 0, that won't work because we're dividing by 0. So you would think, looking at this, we don't have a constant k. But if I was thinking about this on a graph, and I started at 0, 0, and I went up 2 to the right 3, I would end up at this point. So even though 0 divided by 0 doesn't give us that k value, I can still say it's going to keep going through the points. Also, in my equation, if this is like our slope-intercept form, what is the y-intercept? It is 0. So because there's nothing here, our y-intercept has to be 0. So if you see 0, 0, that won't give you the k value that you need, but your y-intercept has to be 0. So that will work with this. So your direct has to have a constant k that goes through exactly, but also it has to go through the word. The y-intercept has to be 0. So keep that in mind. So this is our constant k. So we would write that equation, y equals 2/3x. In the next part, we're gonna determine, are these equations direct or not? Do these look like the y equals kx? That is number 5. Yes. So if it does, then we have to find a k value. What would that be? 2, 3. Does number 6 look like the direct variation equation? Yes. What's the k value? -4/5. What about number 7? No, why not? There's no x. Right, number 8, we have to solve, divide both of these by 2. So y equals 5/2x. Would that be direct? Yes. Your k value would be 5/2. What about 9? Would that one be direct? No, why not? There is a k. It's invisible. It is in the correct order. So it has a y-intercept that's not 0. Because the y-intercept is not 0, it cannot be direct. Right, number 10. Yes, what is the k value? -1. 11, solve. But if I solved it and left it like this, y equals x/2, would that still be direct? Could I rewrite that some way? How would I rewrite it? 1/2 x. So then would it be direct? So either way is direct. It may be written like this, and you have to know that's also direct because it can be rewritten. In cases like 12, most of those will not be direct because it'll have a y-intercept that's not 0, but solve it just to be sure. Subtract 4x on both sides. Divide everything by 2. We have y equals -2x plus 3. Would that be direct? Without solving 13 yet, do we think 13 is going to be direct? Yes, let's see. We subtract 5x. We have y equals -5x plus 0. Leave it off, doesn't matter. So yeah. Okay, so that's how we would determine if something is direct based on the equation. Questions on how we do that? Once you finish, go on to the next page. Now we're going to do the same thing, determine if these graphs are direct. Remember, it has to have a constant k that goes through all the points, and it has to go through the origin. So it's 14 direct. Yes. And then if it's direct, what is the k value? Three over 2. Is 15 direct? No, why not? It does not go through the origin. Is 16 direct? Yes. What is the k value? -1/4. And then is 17 direct? Yes. What is the k value? 3/3, which simplifies to 1. So you should be able to find k, and also find k in different ways on a graph, in an equation, using order pairs or a table. And also look at equations and graphs to see if they are direct or not. This is another piece of what you use this for, to find missing values. So in this, we're going to use the two equations that we talked about. I'm going to rewrite them here. Y equals kx and k equals y over x. So you're going to start with, so in 18, whichever order pair has both an x and a y, so this one, use that to find your k value. That's always your step one. So k equals -4 over 2, which is -2. Once you find your k value, that's going to help you set up your equation, your y equals kx. So in your other order pair, we're looking for y. So that's going to stay the same, y equals. We have our k value, -2. We also have our x value, -6. So then what is our y value? If I wanted to check this, I could take my y value that I just found and my x value that I already had and divide them. And if we get the same k value, then we know it works. You don't have to do that part. You can do that part. It's a good way to check yourself. What questions do we have about this process so far? Let's do another. So in this one, we were solving for y. Let's solve for x now. We have an ordered pair, so let's divide those. 16 divided by 4. So what is k? 4. Use that, put it in your new equation, y equals kx. We have y, we don't have x, so 24 equals 4x. How would I solve for x? Divide it. So that x equals 6. Again, if I wanted to check this, I could take my y value and my x value and divide them. And if it's the same, then I know I did that right. These bottom ones, 22 through 25, are the exact same thing. They just have more words. So for 22, if y equals -18 when x equals 30, find x when y equals 30, what would be our first step? What did we do first in those previous problems? So we look for k, so k equals -18 over 3. That k would equal -6. And then we have to set up our equation, find x when y equals 30. What would that equation look like? $30 equals -6x. So this is just like the one we just did. Divide both sides, solve for x. I'm not going to do the check method, but I'm not gonna write it, but I'm gonna say it. So if I have 30 over -5, it would equal -6. So I know that works. Right, we found x, so let's do one where we find y. 24. If y equals 10 when x equals -4, find y when x equals 12. What's our first step? Find k by doing what? 10 divided by -4. Simplify that, leave it as a fraction. Five halves, -5/2. And then we have to set up our equation. What would that look like? Y equals -5/2 and then times 12 in parentheses. Multiply that, tell me what Y is. Negative, what was that number? Not 40, but close. -30. Do we have any questions, concerns, confusion on any of those? How we did that, how we got those answers, the process? When you have that written down, go on to the next page. Okay, so we are going to do some applications of direct variation, and then we'll talk about inverse. What's nice about this process is what we were just doing is the exact same way we solve things. There's just more words. So we have to figure out what's important, what goes with what, things like that. You guys don't have this part, but you have this part. So when we use direct in situations where one variable goes up, the other goes up. So I could say the more you study, the better your grades are. But these also can go down together. The less you study, the worse your grades in general. So these either go up together or down together. And we'll talk more about some of those examples. Let's read through this first one. The sales at a baseball game vary directly with the number of people attending. If the sales for a game are $12,000 when 800 people attend, determine how many people attend if the sales for a game are $15,000. What do you think is important? $12,000, 800 people attend. What else? The sales for a game at the beginning. No one else besides actually thinks there's anything else important? Okay, for 15,000. Okay. Is there anything else that stands out? What are we looking for? Okay. Are we? Is that what the question asks? Becky? How many people attended for that amount of sales? And there's another word that's really important. The word very direct. So in most of these problems, you'll see words that say very directly, varies directly, directly proportional, any of those. That will tell you this is a direct variation. When we go to solve this, whatever comes before the words very directly is your y. Whatever comes after is your x. And then every time you see those in the rest of the problem, you can label them y or x. So sales is y, number of people is x. So we're looking for the number of people that attend. Are we looking for y or for x? So the hardest part about this is knowing what you're solving for. After you get that straight, then you're just setting up your equation and solve. So just like what we did before, find K, take the first two numbers that you have an X and a Y for, use that. 12,000 over 800. Because this is real light, we want the labels or units in there. So $12,000 over 800 people would be what? 15. So that would be $15 per person. Then we have to set up our equation. We're looking for how many people. We know the amount of sales and we know our K value. How would we set that up as an equation? And our Y equals KX. Then 15,000 for Y, so 15,000 equals KX. Over the rest of that equation. Then we're solving this for X. So divide both sides by 15. X equals 1,000 what? Okay, so make sure you have the correct label. $1,000 wouldn't make sense because that's not what we're looking for. And as we see, the more people that attend, the more they have in sales, but the less people that attend, the less they have in sales. They go up and down. Questions on any of that? Have we got the answer, the process, anything like that? We're gonna do a couple more from this. Any more you want to see from this, and then we're gonna switch gears and do inverse. So for number 2, ounces of medication vary directly with the weight of the patient. If a 120-pound adult requires 3/4 of an ounce of medication, how many ounces are required for a 200-pound adult? What do you feel is important here? Ounces of medication vary directly weight of the patient. 120 pounds. 200 pounds. 3/4 of an ounce. And what are we looking for? How many ounces? Okay, so again, ounces of medication that comes before the words very directly, so that's your Y. Weight of the patient is X. So every time you see something about ounces, that is your Y. Every time you see something about pounds, that is your X. Are we solving for X or for Y? Okay. So then let's start this. How would we set this up? What would be our first step? Isaiah? Solve for K. How would we do that? Look, for the two numbers, we have an X and a Y for 120 and 3/4. Since the 3/4 will be a fraction, put that as a decimal, so 0.75 over 120. That would be ounces over pounds. You are going to get a decimal. What is that decimal? Who has that decimal? this. Now, when you're doing this, you have to think about, does this answer make sense? So let's say you switch these by accident and you got some number like 90. Would 90 ounces per pound make sense? A lot of medication. Something like this would make sense because you usually get small doses for however much you weigh. So we have our K value, we need to solve for Y. How would we set up that equation? Y equals KX. Multiply that, tell me what Y is. One point two five. 1.25 what? Ounces. Does that answer make sense for the amount of medication for a 200-pound adult? Now, if you put the wrong label, like a 1.25 pounds, that would not make sense. Just think about your answer. Does this label make sense with what I'm looking for? Does my answer make sense for what I'm looking for? If you got something ridiculous like 5 ounces or anything more, anything big like that, think about it. That probably wouldn't make sense. All right, questions on that one? We're going to skip down to number 5. And let's read through that one. The income of a computer analyst varies directly as the number of hours worked. If the analyst earns $256 working 8 hours, find the constant of variations. What is important there? So I heard 256 for working 8 hours. The income of a computer analyst varies directly. Find the constant of variation and the number of hours. So they're asking us to find the constant of variation. How do we do that? What is the constant of variation? What are we looking for? K. So define K. K equals Y over X, which is what over what in this case? 56 over 8, because income would be Y, number of hours would be X. And this would be dollars per hour. So divide that. $32 per hour. Did it ask us to find anything else? No, so that's it. Don't do more than what it asks. Do we have any questions for that one? Are there any others on this page that we want to see, do, go over, have questions about? 6. Okay. We'll do 6 and then we'll move on. So for number 6, the gallons of water used to take a shower vary directly with the number of minutes in the shower. If an 8-minute shower uses 48 gallons of water, find the constant of variation. What's important? 48 gallons of water. Sorry. 8-minute shower. And then Omar, what did you say? If the gallons vary directly. the constant variation, and then improvements. So again, we're looking for K. How would we set that up for this one? That would be 48 gallons over 8 minutes. Give us 6 gallons per minute. So now we're going to switch to inverse. So if you want to take a second, stretch, get out of your chair for a second while I pass this out. Right, inverse is going to go a little bit faster because it's really the same as direct, but the equations are a little different. So if direct had a specific relationship where there was a constant ratio, what do you think inverse is going to have? Opposite of dividing. Multiplying, but the end result. What would be the end result of multiplying? So inverse variation equations, inverse variations have a constant product. The equations are written in the form y equals k over x, so slightly different from direct, because we're not dividing. And then to find our product, if we had to solve this for k, how would we do that? Multiply x. It would be k equals yx. Multiply both sides by x, k equals yx, or xy, it doesn't matter. So that is the product that we're going to be using to find k for each of these. So same thing, if we have a constant k that is the same for all of these, when we multiply, then that is our constant k, it is inverse. So if I were to multiply 1 and 20, 2 and 10, and 4 and 5 together, do we get the same number for each one? What is that number? 20. So because it is the same for each, we have a constant k, and we would write that y equals 20 over x. Questions on that one? Number 3, do the same thing, multiply x and y together. What do we get? -12 for all of them. So that would be our k value. How would we write this inverse variation equation? Y equals -12 over x. Okay. This next part, we're going to graph one, but you're not going to need to know how to graph it. You're just going to need to be able to recognize this is what the graph looks like. So if we are given a constant that is 16, that means we have to multiply two numbers to get 16. What times what will give us 16? 4 and 4, 2 and 8, another one, 1 and 16. And because we're graphing this, I can also flip these, so I can say 8 and 2 and 16 and 1. Graph those 5 points on your graph. The ones, this is counted by 2, so the ones you'll have to go with like 4, 4, 2, 8, 1, 16, 8, 2, and 16, 1. It'll look something like that. Then you're gonna connect the points, and make sure you write this down. Draw arrows at the end. To the best of your ability. This is only half of it, because we only did the positives. How else could we multiply to get a positive 16? Two negatives. So we're gonna take all of these and make them negative. Go to order. So -1, -16, -2, -8, -4, -4, -8, -2, and -6, plot all of those. So basically do the same thing, but on the other side. Connect those to the best of your ability, draw arrows to them. And this is the shape that an inverse makes. It's called a hyperbola. When you go on to algebra 2/algebra 3/pre-calc, you'll do more with hyperbolas. We're not going to do much more, except you need to know what the inverse variation looks like. When you see this, you have to recognize that's an inverse variation. So then on the single sheet that I gave you, find the side that has the graphs. We're not doing the graphs, but we're going on to the missing value. Same as direct, we're gonna use our two equations. I'll rewrite them. Y equals k over x, and k equals y times x. For number 7, use what you have to find k. So k equals 12 times 14. Multiply those, tell me what you get. So everyone should be on the single sheet of paper, not the packet. What did you get? Yes. So k equals 168, then use your other order pair to set up your y equals k over x. So we don't know y. We know our k is 168. We know our x is -20. Divide that. So I'm not going to write it, but if we wanted to check this, we would multiply -7 and -24, and we should get 160. Questions on this process? Now we found y, let's find x, so let's do number 10. What would be our first step? For number 10. We are going to multiply two things. What two things? Yes. 21 times -3, so that k is -63. Then we're going to use the other order pair, so this happens to be the first one this time, to solve. How would that look when we set up the equation? and our y equals k over x. Y is -7, so it's going to start off -7 equals -63 over no longer use where did that. So we have -7 equals -63 over, we're missing. And then how would we solve for x? Couldn't multiply 63 to the other side because that wouldn't get x out of the travel. But we could multiply x by both sides. And then solve for x by dividing both sides by -7. So that x equals if I multiply -7 and 9, I would get -60. So that works. Do you have any questions on this one before we do a couple more of this? Okay. Same as direct, these are the same. They just have more words. So let's do 11. If y equals 9 when x equals -6, find x when y equals 3, sorry. So what is our first step? Yes, define k. What would that be? Yes. And then to set up our equation in y equals k over x, what would that look like? Start off with y equals, what is our y? 3 equals -54 over. Same as number 10, multiply x on both sides. And divide both sides by 3. What is x? And -18 times 3 would give us -54. One more of these. We found x, so let's find y. So number 14. Find k by multiplying -8 and -7. What is the value of k? Positive 56. How would we set up our equation? Y equals 56 over -4. What is y? Y. -4 times. We're going to do a couple applications and then we'll be done for today. Flip the single sheet of paper over to the back. At the top, in a situation is inverse where one variable goes up, the other goes down, or vice versa. So the more you travel, like drive, the more you drive, the less gas you have. The less you drive, the more gas you have. One goes up, one goes down. So let's read through this first example. Time traveling varies inversely with the average speed. If a train travels between two cities in 3 hours at an average speed of 65 miles per hour, how long would it take at an average speed of 78 miles per hour? What's important here? Then inversely, 65 miles per hour. Average speed of 78 miles per hour. The 2 city start, that's not really important, but the 3 hours is. So, how long would it take? Right, if you want to highlight the time traveling and the average speed at the beginning, you can also do that. Just like direct, you'll see varies inversely, varied inversely, inversely proportional. Whatever comes before those words is your y. Whatever comes after is still your x, so that part has not changed. So then every time you see something about time, that's y. Every time you see something about average speed, that's x. So what are we looking for? Y or x? How long? Okay. And then the work is the same as we were just doing. Find k. What 2 numbers are we multiplying? 3 and 65. The order in which you put that doesn't matter. Multiply that, tell me what that would be. 195. I'm not putting units with this because it doesn't work the same as direct. And then since we're looking for y, how would we set up our equation? (195 over 78). Divide that, and what you get? 2.5 what? So in this, your end result is usually going to be smaller because you're dividing, unless you're dividing big numbers. But your k value could be really big because you're multiplying. Okay. And in this one, the faster you go, the less time it takes. The slower you go, the more time it takes. Questions on how to set that up? 8, 9, and 10 are all solving for y, so I'll let you choose which one we do. So you see at least one more example. You guys choose 8, 9, or 10. 9. If we have time, we'll come back to it. So for 9, the width of a rectangle varies inversely with its length. If the width is 4 when the length is 18, find the width when the length is 8. What's important there? Width of the rectangle varies inversely with its length. Find the width. The length is 8. The width is 4. And the length is 8. Right? So then we would need to find k. What 2 numbers are we multiplying together? 4 and 18. To get 72. Then when we find the width, is that y or is that x? Whatever comes before the words is your y. Are we finding y or x? Y. How would we set up that equation? Divided by 8. What would that give us? 9. And this one doesn't really have units, so you can just put 9 units. Let's do 11 and then full stop. So if you want to see 10, I can probably help you with that one in a bit. So for 11, the time it takes to bake a turkey varies inversely with the oven temperature. If it takes 3 hours to bake a turkey at 300 degrees, find the constant of variation. What's important? Okay. Time it takes to bake a turkey varies inversely. Oven temperature. 3 hours. 300 degrees. 500 degrees. So to find the constant of variation, what would we do to find that? What is the constant of variation? K. So if we're looking for K, how would we find that? 300 times 3. Which is doesn't ask for anything else, just find K and that's it. Make sure you're paying attention to what it's asking you to find. Right. We don't have a full lot of time, but for the remainder of class, and then I'll in about 10 minutes I'll let you put your test numbers away. You can be working on more practice in the inverse, more practice in the direct. You have 2 delta math that are due tomorrow on direct and inverse. If you did not do, which I forgot to do, I forgot to do that. We didn't get 50% on the linear regression that was due on Friday. So if you haven't finished that, you can also be working on that. So any of those delta maths, any of those practices, if you would like the review, you'll get it when we come back. But if you would like that prior to going on break, you can also continue for that. Be working on any of those things, work with each other. Let me know if you have questions.